Hi, let me tell you about another great Manning book, LLM Reliability, Performance, Hallucinations, Accuracy, and Bias, written by Rush Shahani.
Large language models such as GPT-4 and Palm are revolutionizing various industries by automating repetitive tasks, allowing humans to concentrate on creativity and strategic thinking. They assist in drafting reports, customizing marketing messages, and generating code while enhancing capabilities in law and medicine. LLMs have vast applications in education, entertainment, and business analytics. However, responsible deployment requires addressing biases, ensuring factual accuracy, and upholding ethical standards. The introduction of the Transformer architecture in 2017 revolutionized NLP by enabling models to understand language through connections between words in extended text sequences. Scaling these models to billions of parameters has led to human-like text generation and comprehension. Despite their capabilities, real-world applications must address challenges like hallucinations, inefficiency, and bias. LLMs are transforming various industries. In media, they enable rapid content creation. In customer service, they power intelligent virtual assistants, and education benefits from automated curriculum design and AI tutors. In law and healthcare, LLMs assist in complex tasks with encyclopedic knowledge. Creative fields use LLMs for script writing and interactive narratives. However, addressing risks like bias and inaccuracy is crucial to realizing their full potential. Understanding LLMs is essential for developers and users. They are trained on massive datasets from diverse sources, enabling them to grasp language nuances. Advanced architectures like transformers and self-attention mechanisms allow LLMs to understand context and capture linguistic patterns. The deployment of large language models like GPT-3 and Palm in real-world settings presents several challenges that must be addressed to ensure their safe and effective use. Hallucination control. LLMs can produce content that sounds convincing but is factually incorrect, a phenomenon known as hallucination. These hallucinations can have serious consequences when LLM is deployed to production. For example, in healthcare, hallucinated medical advice could result in harm to patients if incorrect treatments or diagnoses are suggested. Effective strategies include grounding outputs in verifiable facts, adversarial testing, and prompt engineering techniques to minimize the risk of false information. Performance and accuracy optimization. Accuracy is a vital component of performance, particularly in industries like healthcare, law, and finance, where even minor mistakes can have severe repercussions. To build trust, LLMs must provide both accurate and timely responses. Methods to enhance accuracy include retraining on up-to-date datasets, implementing precision tuning, and ensuring continuous feedback loops. Improving real-time responsiveness through techniques like query caching, parallelizing computations, ensuring faster and more reliable outputs. Efficiency improvement. LLMs require massive computational resources, making them costly and environmentally unsustainable. Techniques like knowledge distillation, weight pruning, and specialized hardware can reduce these demands. Bias mitigation. LLMs can perpetuate societal biases due to insufficient diversity in training data. Developers must audit and filter data, improve minority representation, and continuously tune models to ensure fairness. Addressing these challenges will enable the safe and effective use of LLMs across various industries, building public trust and driving innovation.
Get this book at Manning.com